Ethereum Memory Pool. How does it work? The Ethereum blockchain is actually a distributed ledger, just like the Bitcoin blockchain. It offers computing functionality in the form of smart contracts, but at its most basic, it is just a bunch of blocks attached to each other, one-to-one, containing transactions that change the state of the blockchain. Nodes forming the Ethereum network keep a copy of the blockchain, and are the ones in charge of adding new transactions to it and assuring its consistency and validity. The question is, how are transactions added to the blockchain by the nodes? The process can be explained very easily. Nodes receive signed transactions from wallets/users, and if the transactions are valid, they add them to the blockchain. Problem is, nodes might receive thousands of transactions, and blocks are added to the blockchain at a quasi-constant rate. Every few seconds, nodes might also receive different transactions from different users and other nodes they are connected to. We need to be able to have some kind of buffer to store all those incoming, yet to be validated transactions. This is where the memory pool, mempool, comes into play. I will try to describe what it is and how it works from a generic point of view and what side effects they might have. What is it and how does it work? How would anyone add a new transaction to the blockchain? Let's say someone who wishes to send some money to another account. Well, the very first thing that this person should do is to generate the transaction. He or she will have to indicate, among other things, the recipient of the transaction, the amount to be paid, the amount of fees that he or she is willing to pay for the transaction, the transaction signature, signed with a private key using a wallet, for example. Once the transaction is ready, it only needs to be included in a future block in order to be accepted by the network. The way to do that is to broadcast the signed transactions to one, or many, nodes forming the blockchain network. Nodes will receive your transaction and check its validity and authenticity before forwarding it to other nodes in the network. They will check that the sender has enough funds and, more importantly, that the signature is correct. After checking the transaction, nodes will add it to their memory pool. Nodes will recheck all their mempool transactions after each block gets added to the network, since it might contain transactions that invalidate some of the transactions they are keeping in their mempool. The mempool is basically RAM memory within nodes, where they keep all the so far validated transactions they have received but could not yet add to the blockchain. Indeed, blocks are generated every few seconds or minutes depending on the blockchain, and they have a maximum size, meaning that they can only host a limited number of transactions. If the rate at which users are sending transactions to the blockchain is higher than the rate at which blocks can be added to the blockchains, many transactions will have to wait in the node's memory pool. It is important to note that because of its decentralized nature, nodes' memory pools might be different at any point in time. They might hold different transactions. It is also important to note that your transaction might also exist in multiple nodes' mempool at any point in time. Sometimes we refer to the mempool as a single entity/location, but it is in fact a combination of all the mempools that exists at time t. Nodes will pick transactions from their memory pool in order to build blocks to add to the blockchain, but they will not follow a first in first out strategy. They will pick what they will consider the most convenient transactions for them, basically those that pay the highest fees, since they will be the ones to collect them. Once a transaction is finally picked by a miner from its mempool and added to a block, all the other nodes that contain the same transaction in their mempool will proceed to remove it, since the same transaction cannot be added twice into the blockchain. The memory pool of each node is then like the waiting area of a train station, where passengers wait for the next train to arrive and only those willing to pay the most will get in. With the particularity that a single passenger could be at multiple train stations at the same time, and the moment he or she gets into a train, he or she disappears from all the other train stations. Related side effects. Canceling transactions. Nodes are untrusted agents, in the sense that they will always act in their best interest. Like we already described before, they will pick first those transactions that pay the most. This is actually a behavior that we can use to our advantage, since it will give us the possibility to cancel transactions if required. Transactions that have not yet been added to the blockchain, of course. In order to cancel a previous transaction, we need to submit to the network a new transaction from the same account using the same nonce but with a higher fee. Nodes will receive your new transaction and, since it pays a higher fee than the previous one, they will add it to the blockchain first. Ethereum transaction nonces can only be used once for a specific account, meaning that the moment they add the new transaction to the blockchain, the old one becomes invalid and gets removed from the mempools. Front running. Since nodes keep transactions in their mempools before adding them to the blockchain, they have access to their content and can check the output, state change, they will cause to the blockchain in advance. This can potentially be an issue for your dApp. Let's suppose that you are offering a certain reward to the first account that submits a certain value, that hashes into a value that you stored on your smart contract. If someone submits the right answer to a node, the node will have access to that value and can very easily generate its own transaction, copy-paste the content, and add it to the blockchain first, effectively stealing the reward from the honest user. This is just one example of front-running, but there are many more situations in which the speed or order in which transactions are added to the blockchain can have an impact on your dApp logic. You should always keep in mind that this can potentially disrupt it. Join CoinMonk's Telegram channel and YouTube channel. Learn about crypto trading and investing. Also, read Bookmap Review, Vertical Bar, 5 Best Crypto Exchanges in the USA, The Best Crypto Hardware Wallet, Vertical Bar, Bitcoin's Review, 10 Best Crypto Exchange in Singapore, Vertical Bar, by AXS, Red Dog Casino Review, Vertical Bar, Swift Review, Vertical Bar, CoinGate Review, Best Crypto to Invest in India, Vertical Bar, Wazer Peer-to-Peer, Vertical Bar, High Dollar Review.